Hello, good afternoon, sir.
One second, sir. Yes, sir, we are live now.
Okay.
Good afternoon, sir. Thank you for joining this session. This is 1 year, after 1 year, the death anniversary of CEG Gesto, we are doing this workshop. And nice of you to have joined this workshop to conduct this as a speaker. Thank you very much, sir. You can start your session now.
Okay. First of all, I thank Mr. Parthan to come here and give a small presentation on behavioral understanding of urban travel decision. So first I'll read his resume. So Mr. Parthan has done his BE from NSS College of Engineering, Kerala, and he has done his MTech in transportation from NIT Warangal, and he's a rank student also. Presently, he is doing PhD from Madras, and he is in the final stage of submission, and his area is mainly on behavioral modeling. So he has published in paper in various reputed journals, and his areas of interest is mainly choice modeling of passengers. So his work experience is he worked as a project officer in advanced traveler information system for Indian cities for Ministry of Urban Development, Government of India. And then he has worked for Center for Excellence in Urban Transport, another project in Ministry of Urban Development, India. Then he was a half-time research assistantship at IIT Madras. So once again, I welcome you, sir. Over to Mr. Parthan. Sir, you can start your session.
Okay, sir. Thank you, Professor Vivek, sir. I once again thank faculties at Dhanansa College of Engineering for giving me an opportunity to present on my understanding of how do you go about modeling or understanding urban travel decisions. That being my focus area, and that also is predominantly the area that I work with my current MTech students at BMS College of Engineering. So I thank you once again. So I hope we can get into the topic for this afternoon. I've titled it as Behavioral Understanding of Urban Travel Decisions. Although I would want to broadly put it as application of certain tools like discrete choice theory, discrete choice models, which can aid us in understanding urban travel decisions. Now, the moment I say urban travel decisions, so I would want to put it I would want to set the context in beginning itself by saying that I'm only going to concentrate on strictly urban travel decisions. So the moment when we say urban travel decisions, the question is, what are the different travel decisions that we generally take or generally make when we want to make a travel? So what are the different dimensions or different choices that we come across and we make decisions about in a day-to-day manner, on a day-to-day basis, in a regular urban, if you can say, commute. Of course, I'm not going to talk about only commute trips in this presentation, but still, urban commute generally contributes to somewhere around 70 to 75% of the trips that happens in an urban scenario. So let's go about understanding from the fundamentals. So a typical urban transportation planning process is all about estimating the travel demand. Now, what is travel demand? How do you feel that there is demand for travel? As we already know, that travel by itself is not activity. It's a derived activity, in the sense that in an urban scenario, most people, or all people, I can put it, if you want, we can say it, all people do not travel for the sake of traveling. The travel is not an adventure, at least within an urban framework. People travel because they have a need at the other end. They have some activity to perform at the other end. So why do people travel? What is the demand for travel? Now, why is it important? We will see in a couple of slides. But at least broadly, we know that we need to know how much or what is the number of people, or how many people are roughly traveling in the city, within the premises of the city. Now, why is this important? We will have to design infrastructure for facilitating this travel. So we need to have at least a rough idea about how many people are traveling. So now, how do we experience this travel demand? This travel demand is observed or felt as traffic on different transportation networks. Now, what I mean by different transportation networks here is, say, road networks, okay, cycle paths, metro. These are different transportation networks. Bangalore is a city which has metro. For example, you take a city like Chennai, it has systems like suburban. Of course, Bangalore also has suburban systems, but not as wider one as Chennai. It's a much established and wider network in case of cities like Chennai. So different cities, you have different alternate transportation networks that happens. If you take city of Bombay, you have also monorail there. You have metro. You have the existing suburban. You have the bus service like the BMTC here. We have the best there. And apart from all of this, you have the regular highway network, which facilitates the your usage of personal vehicles like two-wheeler, car, cycle tracks, or footpaths, or skywalks, which by itself is a separate non-motorized walk network. So we have different transportation networks. So travel demand manifests itself as a traffic, as congestion or heavy volumes on some of these networks. So now, travel demand can be understood as a manifestation of aggregated effect of individual travel decisions. So every individual in the city who travels, who intends to travel, makes certain decisions when he travels. And when the aggregated effect of all these decisions come together and they manifest as traffic on road network. Now, what are these individual travel decisions? The questions are very simple. For a given individual, how many? Now, what is how many? How many trips do I make in a day? It's not a preconceived decision that somebody makes. Say I don't decide on the today morning itself how many trips I am going to perform. But at the end of the day, I at least can get to know about how many trips I would be performing. Then, of course, the first question should be whether I am planning to travel or not, given the current situations with respect to pandemic, and even otherwise with the advent of all the internet facilities and tools. We are aware of many facilities by which you can avoid travel. For example, internet banking, or tele shopping, or even ringing up somebody, some shop, and asking them to bring over food, ordering food, and things like that. There is a lot of travel that is being bypassed. So in first place, whether we want to travel or not is the first question. And given the decision that we have already decided to travel, the next question is, where do we want to travel? Of course, this question doesn't appear when, in case of commute, for example, if I'm going to work every day morning, I don't ask this question as to where I should be going. But at least this is very relevant in case of, say, recreational trips, shopping trips. I would want to choose the places. So destination is a decision. How? Next question is, how do I travel to this place? By what mode? Should I travel by walk? Should I travel by cycle? Should I use my two-wheeler or car? Should I be traveling by bus or metro? So what mode do I use to reach this place? And even when I use that, some of these modes are not going to be unimodal, in the sense that, suppose I am going to use bus, obviously there is going to be a walk trip, or an auto trip, or some other kind of an access or an egress component which comes along with that. So some of these modes are not unimodal. They are not the only mode that you will be using if you're going to use them. So which mode are you going to use? Then through which route? Now, conventional urban transportation planning process, or so to say, the 4-step planning process, talks about only these 4 components: how many, to where, which mode, and which route. So there are also additional decisions that you make. When? when do you travel? What is the departure time for that? At what time do you leave? With whom do you travel? You go with your family member? Then how many? How many people do you take with you? Of course, some of these decisions are interlinked. For example, if I am going to use a car, then maybe I might take my family members. Or maybe because family members are going to come, I think about using car. So some of these decisions are interlinked with each other. And so to say, they are not independent of each other. And there are also many other decisions that you make. Okay. And there is also context for this. What is the purpose of traveling? For what purpose are you traveling? That also affects many of these decisions. So these are some of the travel decisions that we typically make on a given day, and which manifests itself as travel demand, which needs to be quantified. Now, what is the need for estimating this travel demand? Of course, the first and foremost objective being to optimize the investment in infrastructures in the future, and to identify areas which have shortage and excess of infrastructure. Some modes or certain modes or certain components we invest extra, and certain other areas we don't. So if we want to know exactly where to invest how much, then the government should clearly have some idea about what is the travel demand that is happening. And the most important requirement or the need for travel demand estimation is to aid the policymakers, the decision makers, on the right kind of infrastructure. What is the right combination of infrastructure that we require? Okay, now every city has its own kind of combinations. What is the right set of services that we should be offering? Now, we have Ola, Uber, and other demand responsive systems that are currently coming up in the last 8 to 10 years. It has been in use to a great extent. Now, is it good? Is it bad? Has it improved the existing travel situation? Or has it worsened? These are some of the things that we need to ponder about. So is it the right policy, or do we need to, are they good, are they bad, or is it something gray? We need to think about this. So travel demand estimation can give some idea on some of these higher level decisions to be made. And what are the type and alignment of these new facilities? So at least for some of these objectives to be fulfilled, we need a clear-cut idea of what is the travel demand. So now over to the conventional four-step planning process, or for urban transportation systems, say, they go through like this. So what you see on the left-hand side here is a typical steps that we title them as these steps. First step is called the trip generation. Second is called the trip distribution. The first step, we get to know the total number of trips that is being produced and attracted. We split the city into traffic analysis zones and analyze them. Now, second step, we distribute them. We get to know from where to where the trips are moving. Third is the modal split. We get to know what is the percentage or share of trips that is being conducted in the different modes. And last, the traffic assignment or the route assignment, where we assign these trips to their respective networks and estimate the volumes and travel times and V/C ratios and whatnot. So at an individual level, this is an aggregate level. This is whatever we just now discussed is an aggregate level travel demand. So at an individual level, whether I should go out or not, where to go, how to go, and which route. So these translate as choices of trip frequency, how many trips I should be performing, destination choice, mode choice, and route choice. Now the word choice is appearing in every step here, which shows that these are all very conscious choices that individuals make. So we would gather more information with respect to travel demand if we analyze these decisions at a much more magnified level. So if we are able to peek into each of these choices with much more clarity, we would have a better idea about what is the travel demand that we are experiencing. So as I already discussed, these are the 4 steps, and this translates into travel demand. So here I am highlighting it as PIJMR, where I refers to the origin zone, J refers to the destination. So IJ covers from where to where I am traveling. M refers to the mode, R refers to the route, and P refers to the purpose of travel. So TPIJMR put together talks about the travel demand for a given trip purpose from zone I to destination zone J by mode M through route R. So this is your travel demand. Now I now slightly narrow down my discussion today. I'm predominantly going to talk about what is called choice of mode, or what we generally call it as modal split. So the third step, which I named as mode choice, is what I am going to put focus on. Of course, the things that I'm going to discuss and the tools that I'm going to discuss is equally relevant for any other choice dimension. By the way, it's not only applicable only for transportation systems. In fact, the theory of choice itself was borrowed by transportation planning people from economics. So it's mostly econometrics. So you can study any choice, any choice dimension of any other interest, which let it be marketing, let it be research, let it be sociology, let it be personal life itself. Many of this philosophy of choice is a useful tool in some of these things. So why should we study modal split? Because as you see on the roads, this is of course the picture represents a European or a US condition, a homogeneous traffic condition, where it's predominantly personal vehicle intensive. But the condition is not different even here. For example, very recently we conducted a survey in Bangalore. Personal vehicle share for work trips, 54% roughly is two-wheeler and 21% is roughly car. So that contributes 75%. So that means roughly 3/4 of the city is using personal vehicle, motorized personal vehicle, two-wheeler and car for work trips. So if 3/4 of the city for work trips is traveling on personal vehicles, then what would you expect? It has to get congested, isn't it? I'm talking about Bangalore city. The survey was conducted only 2 years back. So we should not be surprised by seeing what you're seeing in the city. It's congested because it is congested, because of our choices that we are making. So for this reason, we have to behaviorally understand why people make these choices, and is there anything which I can do to tweak this, to change this, to push the system to much more sustainable modes, so that the environment that we are living in is much more safe, healthier, cleaner. We're able to breathe more cleaner air, and we have much more wider space, and we create much safer environment for our future generations. More precisely, why should we study mode split, or why should we study mode choice? One of the applications is, say, an organization like BMTC or Metro, if they want to fix their fares, what is the right fares that I should fix so that I can raise my ridership for my public transport modes? What should be the right fleet size, ideal fleet size? What should be the frequency in which I should be operating? What should be the schedule? And what should be the comfort levels of operations? Okay, we have various gradations of service that BMTC offers. Okay, it has a red line, a blue line, a green line. So what should be the comfort levels that it should be operating? So all these things, you can get a great deal of information if you are able to understand mode choice behavior. You're able to study mode choice behavior. And we will be able to tell people like BMTC what they should be doing if we collect proper data and build simple mode choice models. Further, we will be able to understand what is the effect of certain policies or certain scenarios. What is the effect of, suppose I raise my bus fares or raise my metro fares. How much is the change in ridership that is going to happen? So if I'm going to lose some of the metro riders or some of the bus riders, where are they going to? Are they going to use two-wheeler? Are they going to use car? Or are they going to use some of the demand responsive systems like Ola, cab, Ola, Uber, or some of these services? Where are these people going to move? What is the effect of congestion pricing? If you are able to if you're going to charge for parking at metros versus offering it for free, is there any improvement in ridership that is going to happen in metro? So some of these policies that we want to study or analyze, mode choice models can help. So now, till now I was using the word mode split. Okay, this word mode split actually originated in more homogeneous conditions where predominantly 90% of the users are personal vehicle users. So it was just a split between personal vehicle versus a non-personal vehicle, where only the case was binary or maximum 3 modes. But a country like India or any other Asian country for that matter, owing to its wide spectrum in economic profile or the kind of variety of income holders that we have, the kind of modes that we have also is different, right from walk to two-wheeler to car. Car also we have different varieties, luxury cars, sport cars, small cars. Okay, again, we have an umbrella of alternatives under what is called intermediate public transport system. You have company bus, company cabs, auto rickshaws, shared autos, cycle rickshaws. We have the demand responsive systems like Ola, Uber, which again come under intermediate public transport systems. We have public transport systems like suburban systems, suburban railway systems, or public transport like BMTC, metro, light rail transport. So there are many variety of options that come into picture. So no more we can use the word mode split, and that's why we'll have to use a better term, mode choice being the obvious choice. So now we have to study the behavior with respect to individuals for the choice of this mode. So often this behavior is influenced by the feelings and emotions of the decision maker. These feelings and emotions, we can call it a status quo, or how do they, how sensitive are they to certain attributes of either the alternative that they are choosing or the system that they live in. And as and when they keep using some of these transportation systems, they form opinions, they form thoughts, they have certain beliefs, and based on that, and there are also obvious experiences that they have, which again translates into behavior. So this figure is trying to explain this cycle of how people have their own sensitivities. Based on that, they behave, and then they have experiences, and that experiences form their opinions and thoughts and beliefs. Some of the beliefs are strengthened, some of the beliefs are broken, and then it again contributes to your behavior. So your behavior is a continuous process which you keep learning, you keep seeking, and then it keeps changing. So this means that we have to have better understanding about how a choice process itself functions, how people make choices, how are decisions made. Of course, this slide is not unique for mode choice decision. This slide it's applicable for any choice that you make. So obviously, the first component of a choice process is decision maker. The decision maker could be an individual, could be a family, could be an entire village, an entire zone, an entire city, an entire country. For example, elections. It could be group of companies. It could be anything. So first, you need a decision maker, and the decision maker obviously is facing a set of alternatives or options. So alternatives are basically the options that is available for the decision maker to choose from. So in this case, in case of mode choice, it will be the modal alternatives like two-wheeler, car, bus, train, which is available for an individual to make choice from. And finally, what he chooses is what is called choice. So alternatives, I am differentiating, I am using the term alternatives, which is different from choice. Choice is finally that particular alternative that you pick up from this. Third and most important component is the attributes. Attributes referring to attributes of the decision maker himself. In this case, it could be his personal characteristics, like whether he knows driving knowledge or he has driving knowledge or not. Does he have a two-wheeler or a car? How many members are there in the household? Is he employed or not? What is his income? Is he married? What is the size of the household? Okay, there are various factors which affect. These are individual characteristics. Then we will see some of these attributes. Then there are also other attributes which are specific to the alternatives itself. which again we will see. Alternatives to say, suppose two-wheeler, what is the cost? What is the travel cost that two-wheeler or car incurs for a given trip versus what could be the bus fare or the metro fare for the same trip? So travel cost is one attribute. Travel time that you will incur, waiting time, number of transfers, frequency of service, schedule. These are some of the attributes of the alternatives. And finally, last but not the least, the decision rule. The decision rule is an information processing mechanism, is a heuristic, you can say. It's a process which allows all this information that we have with regards to the decision maker, the alternatives, and its attributes. And this information processing mechanism uses all this information to aid the decision maker in arriving at his choice. So these are the four necessary components of a choice process. Now, the moment I start talking about choice, at least in case of mode, there are different options that are available. So we use the term choice set, or say the set of alternatives that is feasible for an individual. So now you can see that different people have different set of alternatives available. The first person here has a two-wheeler, as a car, cycle, auto, and a metro. Whereas you see that the second person doesn't own a car. He only has option of carpooling. Of course, he has a two-wheeler, suburban. He has a company bus service. His employer is providing him transport facility, whereas the first person is not having that option. The first person is he is having access to bus. So there are certain alternatives that are a different set of alternatives that different people choose from, or different people are having access to. So the set of alternatives from which the person chooses, makes his choice, is called the choice set. Now, for a given individual, suppose this person, he says that he is having class at 9 and he is already late, so he can't board a bus. So he decides to take a two-wheeler. So then what are the attributes that he is probably thinking about? It's the travel time. How much time will I take to reach my destination? What is the fare? What is the distance? So he's making essentially a trade-off between some of these attributes: travel time, travel cost, distance. And he is also sensitive to some of this. So he has attached certain weightage to each of these attributes with respect to travel time, travel cost, or distance. And he associates certain weightage to these attributes and finally arrives at his choice. So there are a set of attributes that the person is looking at, attributes such as travel time, travel cost, and distance. And of course, the decision roles also comes into play in aiding him to arrive at his choice. So as I already said, most models, conventional models used to assume that one choice set is available for everybody. So irrespective of whatever they own or have access to or not, one set of alternatives, one full set of alternatives, which is a universal choice set. So suppose Bangalore has Bangalore has options of metro, suburban, bus, walk, two-wheeler, car, auto. Then the same set of alternatives is assumed for all individuals, which is not the case actually. Case will be something like this. It will vary again. It will vary for different people. Again, I am assuming here that he has access to cycle. He has access to two-wheeler under the condition that he owns them. Suppose he do not own them, then that also is not available. Suppose a person doesn't have a smartphone, or he doesn't have anybody in his household, in his family who owns a smartphone, then probably carpooling is not a necessary option for him, assuming it to be a demand responsive system. Of course, people can do carpooling among their friends, but again, somebody needs to own a car in that case. So suffice to say that the set of alternatives that people choose from is different. Now moving to the next component, which is attributes. So attributes of alternatives. The travel time, travel cost is something which we already discussed. The frequency. So for personal vehicle, this doesn't come into picture, but suppose it's bus or metro. I would want to know at what frequency this is operating. What is the headway? How much will I have to wait? What is accessibility? The accessibility could mean a variety of things. Accessibility could mean how far is it from my home? How far is the railway station from my home? Do I have modes which take me to that place easily? And after having reached that, how much time will I have to wait in the ticket queue? How much time is it having elevated stairs which I have to climb? So how far is it accessible, that system by itself? Reliability. Now reliability here refers to how reliable is the system. Now reliability is, today if I'm a regular commuter and I am a bus user, every time one bus exactly comes at the same time, even if it is 5 minutes late, it is consistently late, then I would call it reliable. It is very reliable. It will always come 5 minutes late. But today it comes 5 minutes early, tomorrow it comes 5 minutes late, then it's not reliable. So reliability talks about the variance in arrival times. So a variance in arrival time of a bus is one example of how reliable a system is. So reliability is another attribute of the alternative. So services like metro or suburban have great reliability. We know that their arrival times are almost, they are very sharp. Unlike in case of buses, obviously due to the congested network. Comfort. How do people feel? How do they feel? Are they comfortable? Are they not comfortable? Do they feel safe, secure? In terms of some of these alternatives. These are some of the other attributes which affect the choice. Trip-related attributes. These are attributes related to the trip of that individual. So how far is his trip distance? So how far is his workplace from his house? What is the time of day that he is traveling? What is the trip purpose he is traveling? How many people are traveling with them? Who are they? Okay. If old people are traveling probably with him, then probably he would use personal vehicle. If kids are traveling, he might choose personal vehicle. Whereas suppose some of the friends who are much more able traveling with him, he would not mind using public transport systems. And so there are a variety of factors which affect the choice, the trip level attributes. Whether he's picking up or dropping off somebody, whether it is a work-related trip. So these are some of the trip-related attributes which affect the choice. Finally, personal or individual or household characteristics. Age of the person who is traveling, the gender, the educational status, occupation. Okay, I would dare to say status quo is one thing that's also seen in India. For example, suppose some person is working in an MNC, in a multinational company, and he's climbing the ladder and he's reaching upper layers of managerial positions. He would be forced, because of his peer pressure and things like that, he would be forced to use car probably. Okay, not necessarily, but it is generally a behavior that we have seen, that people, when they climb the ladder in their career, they generally tend to use personal vehicles more, car more, even though they would love to use other modes, because they need to maintain a certain decorum and things like that. So occupation, status quo, or I don't know, peer pressure, if you want to put it like that. Of course, there are always exceptions to this. Income, vehicle ownership, marital status, spending habits, use of free time, all these factors affect the choice. Often people ask in a survey form, when we ask about income, people get offended and people don't reveal their original income, while actually income is one of the major contributors of your mode choice. So some of these attributes are very, very important. So now over to the tool that we will be using to understand some of these choices. So the dependent variable that we are looking at is nominal in nature. Here the choice of mode is nominal in the sense that nominal means that it is not like, suppose I have 3 modes available in my choice set: two-wheeler, car, and bus. So one doesn't have an additional advantage over other in a general sense. So it's not like car is greater than two-wheeler or bus is greater than car. There is no, as such, any ordinal relationship between them. Such variables we call nominal in nature. So the dependent variable here, the mode is nominal in nature, and the independent variable are, it's not right to actually call statistically them as independent variables. It's more meaningful to call them as explanatory factors. The factors which we use to explain the observed choice. So to say, here in this case, it is the mode. So the attributes that we were discussing till now are the explanatory factors. So they could be both discrete or continuous in nature. It could also be binary categorical variables. The dependent variable is a choice, and because of that, we tend to use what is called discrete choice models. So discrete choice models is generally the tool that we resolve to. Not only in case of mode choice models, there are the discrete choice models with respect to destination. There are destination choice models. There are route choice models. There are, of course, there are mode choice models. There are departure time choice models. There are activity choice models. So whichever is the subject of choice, whichever is the choice dimension that you're studying, discrete choice models could be applied as long as your choice dimension is a discrete quantity. Okay. So the general set of rules that under which discrete choice models are applicable is, the first is the set of alternatives must be finite. The number of alternatives must be finite. You should have a finite number of alternatives that you're looking at. And the set of alternatives should be mutually exclusive. That means a particular outcome can be only represented by one choice or classification. You should not have multiple alternatives which have a huge overlap or which are almost the same. So the set of choices or classifications must be collectively exhaustive. Yeah, if you want to have a comprehensive understanding of how people make choices, then you should include all the set of alternatives that exist in the city in this case. So the basic assumption of the discrete choice model is, suppose a trip maker I, an individual I, faces j options, alternatives. So I'm using the index j, and the number of alternatives could be 1, 2, 3 up to j. Then the individual is assumed to perceive or associate certain usefulness with each of these alternatives. For example, if I have 3 alternatives, A, B, C, then as a decision maker, I'm assumed to associate certain usefulness with these alternatives. So this usefulness is otherwise called as utility. And this utility represents the attractiveness of that alternative. And then comes the principle of this utility theory assumes that the users and suppliers, that means the decision makers as well as the people who operate the system, have complete and perfect information about these alternatives. So, and users are considered to be rational in choosing alternatives. What does rational mean? They are consistent. That means next time you again give them the choice A, B, C. First time they made the choice A, second time also they will again come back and make the choice A, which need not be the case. And transitive choices. Transitive means, suppose utility of A, an alternative A, is greater than utility of B, and utility of B is greater than utility of C, then utility of C is automatically greater than utility of A. This relationship holds in the utility theory. So to say, utility by itself does not have a scale, but it is ordinal in nature. So the utility that we are talking about is ordinal utility, or it's kind of a cardinal utility. So it's an ordinal utility that we are talking about. And switching between alternatives is costless. That means leaving alternative A, if I go and choose alternative B, it is not assumed to cost anything. Okay. And finally, utility cannot be aggregated across population. It's not an interval variable or a ratio variable which I can add up or subtract with respect to other members. You cannot necessarily perform any other operations. You cannot aggregate utility across population. For example, if I have 3 zones, I can add up the population, but I cannot do like that with respect to utility. So these are the fundamental assumptions under which utility theory operates. Now, what is the nature of this utility? There is certain uncertainty which is associated with this utility. We as analysts, because we are the people who are analyzing choices. So when we analyze this choice, we see that we don't know everything about the decision maker. We don't know everything about the alternatives. We don't know everything about the attributes. So there is something missing for us always, even when we collect exhaustive information through surveys and whatnot, through household interview surveys and whatnot. We seriously are not in full capacity to say that we know everything about them, everything about their choice or decision making. So we as analysts do not know all the factors that influence choice behavior. So there is certain uncertainty associated with this utility. So the utility that we are talking about is not a deterministic one, it's a random one. So there could be certain deterministic components of utility, but there is also some random components, some unmeasurable, some unobservable component in the utility. And as I already said, travelers do not always make same choices, but that means they are not consistent. So if it was deterministic utility, I can say that they need to be consistent, but sadly that's not the case. People change their choices and they are not consistent. Given the same situation, given the same choice construct, given the same set of attributes of the decision maker as well as the alternatives, you should not be surprised if you are going to see that the same person would choose a different alternative. The reason being that they are not strictly rational as we assume. Now, what is of interest? Why should we do all this? What is the final outcome from all of this? We are not interested in including all possible variables that affect behavior. We are not certainly expecting that. We don't want to dump 100 variables into this model and find out what is happening. But we are interested in some of the policy variables. Taxes, fares, say fuel costs, waiting time, some of the level of service operations like frequency, at what headway should we operate. So some of the things that we looked at in terms of why do we need to study more choice are some of the policy variables that we are interested in, so that we can try to modify or influence individuals' behavior and thereby improving the transportation systems that we use. And we are also interested in social or demographic profiles, certain homogeneous groups, certain heterogeneous groups, so to say, certain groups. We want to identify certain similarly behaving different groups in the city. So certain people behave differently from certain other groups. So we also want to look at what are these different set of people, what is their characteristics. Now this is something which I already discussed. Why do we have something? Why is utility random? It is not deterministic. Okay, I already said that there are various applications of discrete choice model. You can study route choice, you can study car ownership or vehicle ownership, you can study destination choice, activity choices and whatnot. Now, finally, about the decision rule. So there are a variety of umpteen number of decision rules that is available in literature, but conventionally, the workhorse of mode choice models are, so to say, any transportation dimension that has been studied, utility maximization, or more accurately, random utility maximization. This is a decision rule which has been in use for almost at least now 50 to 60 years. This has been the most popular decision rule that has been in use. Now, what is utility maximization? Now, utility, as we already discussed, is a latent measure. Now, why am I saying it is latent measure? It is latent to the decision maker himself. It's not like the person who is making the decision, he knows exactly what is the utility. It's not like there is some number that is associating. But we as an analyst are trying to give some quantitative measure to this qualitative attribute. We are trying to quantify it so that you can convert it into something tangible. Okay, so in that sense, utility is a latent measure. It's a hidden measure. It's not very well evident to the decision maker. And at the face of it, even for an analyst, before he builds a model, utility is not known. So it is a latent measure even to the analyst, even before he starts modeling. And the decision maker would choose that alternative that maximizes. So given a set of alternatives A, B, and C, and the decision maker attributes certain usefulness to these alternatives, if I can call it as utility of A, utility of B, and utility of C, then as per utility maximization principle, the decision maker will choose that alternative for which he perceives maximum utility. That's what is the principle of utility maximization. So that means among UA, UB, and UC, if UB is the highest, then the decision maker will end up choosing UB. This is the idea of utility maximization. Now, functional relationship. Now, what is this utility? The utility is basically a function of attributes that we already talked about, attributes of both the alternatives as well as the decision maker, and certain other non-measured components. So if I want to give you a simple example, so here is an example. You have three modes: car, bus, and bike. And this is my utility equation. So there are two attributes which influence the choice: cost, travel cost, and the waiting time. So here I have given the attributes. Okay, the cost by travel cost by bus, travel cost by car, and travel cost by bike. Similarly, I have also given the waiting time with respect to this, and I can use this equation. So the 0.5 and 2 that you see here are nothing but the weightages or the sensitivities of these attributes, travel cost and waiting time. So to say, they are actually representing the amount of importance that people on an average attribute to these characteristics. So how with respect to travel cost and with respect to waiting time, what is the weightage or importance people associate with these characteristics? So if I substitute these values here, 10, 5, 25, 1, 15, 0, we will get utility. So from that utility, we can find out which is the most desirable or the second less desirable, etc. So what we do is, finally what we observe is the choice. So we do the reverse engineering. From the choice, we come back and find out what are the sensitivities. Now, in this particular case, I have given you the weightages or sensitivity, minus 0.5, minus 2. But actually, when I say I want to build a model, what I do is I come back, I do reverse engineering and find out and estimate these coefficients. So these are the answers that I get if I apply these values here. So you can see that cost by bus and waiting time, when I apply that, the utility of bus works out to be minus 15. Utility by car works out to be minus 14.5. And utility by bike works out to be minus 12.5. You can see that the highest utility is for bike. Okay, don't see the numerical number, it's in negative. So the highest number, minus 12.5, is the highest of all of these three. And because of this, from this we can understand that the person has greater chances or greater probability of using bike if these are his attributes. Now these attributes will vary from person to person, and because of that his utility also will vary. Utility valuations will also vary, and because of that his choice also will vary. So as we already discussed, the utility is completely it's only partly known to us. So in this case, if I want to know the full utility, then I know a part of it, minus 0.5 into cost, minus 2 into waiting time. This is what I call the deterministic component, which is measured, which is known to the analyst. But of course, there is something else which is random, which I completely don't know. There are many other factors which come into picture, which is not measured by an analyst, which is unobserved to the analyst. And because of that, there is certain randomness. So with respect to utility, I can only talk in terms, there is uncertainty associated with respect to utility. And wherever uncertainty is associated, it is better to talk in terms of probability. Okay. So as I already said, there is a systematic component V, and there is a random component. And because of this random component, with respect to each mode, I will only be able to probabilistically tell what is the probability of choosing that alternative. So we can convert these utilities into some sort of probabilities. So we're doing all this, there is some math behind this, I'm not getting into that. So we get some nice, if we make certain assumptions about this error terms, if we conveniently assume something about these error terms. So in this case, general way is to assume what is called Gumbel distribution, type 2 extreme value distribution. If you assume that these error terms are Gumbelly distributed, then we will get one nice expression like this that you see here. E power beta xn. Beta xn is nothing but my V, which is, as I already said, the deterministic utility. So e power V by 1 plus e power V. This is in case of two alternatives. If I have a two alternative case, say a two-wheeler versus car, then the probability of choosing an alternative, probability of choosing two-wheeler is nothing but exponent of utility, deterministic utility of two-wheeler by 1 plus exponent of V two-wheeler. And of course, I can extend this phenomena for cases of more than two alternatives, where it will lead to what is called multinomial logit probability, where it is the alternatives of more than two. Okay, so again, if I make the similar assumption with respect to error terms, I will get a nice closed form expression, which is called multinomial logit expression. Okay, and how am I estimating these coefficients? What is the tool that I am using? Just like in case of regression, the estimator or the tool that I'm using is ordinary least squares. So in case of probabilistic models, in case of in discrete choice model, the estimator or the tool that we are using is maximum likelihood estimation technique. I'm not getting into the details of maximum likelihood estimation technique. They're self-learnable and understandable. Suffice to say that this likelihood is nothing but the measure of goodness of fit of the model. How good does the model that you have built fit the data? So fit what you actually observe as choice. So the idea is to maximize that fit. So it is something like, tell me what set of coefficients, what set of betas. Betas means, earlier I said, the weightage 0.5, minus 0.5, minus 2. These are nothing but your coefficients, betas. So these betas is what finally we want to estimate. The sensitivities is what we want to estimate. So what should be these betas given the attributes? X is nothing but my attributes. What should be this beta such that my likelihood is maximized? So that's why this technique is called maximum likelihood estimation technique. So what should be this beta such that the likelihood of the model improves? So to find that beta which maximizes likelihood. Now, what are the practical issues that we face? There are issues with respect to choice set or consideration set. Now, in case of mode, it is much simpler. The number of alternatives are really finite. But whereas if it's choice of a talcum powder, suppose you are entering a shop, a market, and you want to choose one powder, talcum powder, then the variety of options available are actually explosive. They are more in number. Okay, so the number of choice sets that can come out it can blow off. So you don't know exactly what is the set of alternatives that he's choosing from. So that's one issue. You don't know clearly what is the choice set. In many cases you know, but in many cases you don't. Now, as I already discussed, we don't know all the variables which affect the utility. And there are many attributes which you cannot measure. For example, some people are comfortable in a crowded environment, whereas some other people are introvert. They don't like to travel in a crowded environment, or they like to talk to people. All these affect choices. So some of these factors are not picked up by any intensive data collection or any modeling exercise. And the last but not the least is we need, all this depends upon quality data, proper sampling, and good representative sample. Okay, and this is required for all modes. The modes that the person has chosen, as well as the modes which the person has not chosen. So we need to know the attributes of the modes that the person chose, as well as the attributes of the modes which the person has not chosen. So that requires some effort. Now, I move on to a small case study which we did as part of our work based on the data collected in Chennai. So it was done, the data was collected by face-to-face interviews. This was data of working people. So as you can see, sir, sorry to interrupt. Vivek sir, how much time do I have?
Hello. Hello. Tell me.
Have I jumped the time or?
No, sir. You can take 5 more minutes extra.
Okay. Okay. Sir.
Okay.
So this is roughly the profile of the data. So as you can see, the average household size was 4.37, and it was matched again the census population to show that the sample was representative of the population. You can see that the two-wheeler shares in Chennai city. So this is Chennai city in 2007. So 42% of the people travel by two-wheeler for work. So this is only about work trip. Followed by bus 20%, train 17%, followed by intermediate public transport 9%, of which company bus takes 6%, auto 2%, share auto 1%, car roughly contributes to 6%, and rest 6% by non-motorized. Non-motorized includes both walk and cycle. So as I said already, these are the different modes that are available in Chennai city. So we use the similar discrete choice models and try to come up with, so these what you see in this table are the various attributes and their coefficients that was estimated using the discrete choice models. Okay, so the first set of factors are the constants. As in case of regression, we use constants in this case also. So your utility expression is nothing but an expression which is exactly similar to a regression expression, and the interpretation is also almost similar. Okay, now as you can see here, the travel time coefficient. The travel time coefficient, as you can see, is negative. And the in bracket what I have given is nothing but the t statistics, which shows that it is significant at 95% confidence level. If I want to just explain one of these attributes, say travel time. So the negative coefficient means that as and when the travel time increases, the probability or the utility for the alternative, whichever that be, I have used it generic because generic means I have used the same coefficient across all alternatives. So it means that with increase in travel time, the utility for all alternatives come down, which is logical. So if the travel time of any alternative increases for a given trip, as a decision maker, I'm not going to like it. So it's basically a disutility variable for me. So my utility for that alternative will come down if the travel time increases. So the negative sign indicates that. And 0.05 is the weightage assigned to that attribute. Okay, and when I come to cost, so I have used, instead of cost, I have used cost per distance. So I have used two-wheeler travel cost, car travel cost, bus travel cost. So you can see that the travel cost coefficients are different. Minus 0.15, minus 0.25 for car, bus, minus 0.138, and minus 2.51 for train. So what do they mean? They mean that the cost per distance value is not, or to put it much more simply, I'll take it only as cost. So 1 rupee travel cost in train is not equal to 1 rupee in two-wheeler. So the weightage that I associate with 1 rupee increase in bus fare or train fare is not as same as a 1 rupee increase in my two-wheeler travel cost. So here, if you see, the negative sign indicates that these are disutility variables, just like in case of travel time. I'm not going to like any increase in travel cost, so it is going to give me negative coefficients. So negative means with increase in travel cost, the chances of choosing or the utility for those alternatives come down. So the negative sign indicates that. And the magnitude 0.15, 0.25, 1.38, 2.51. So I have to now compare only the absolute magnitude. Here you can see that the train is the most, the train cost is the most sensitive. The people are most sensitive to train cost and bus cost than car and two-wheeler. And you see it's 0.15 whereas 2.51 in case of train. So the magnitude is much more higher in case of train. That means 1 rupee increase in train is going to affect more than 1 rupee increase in two-wheeler. It will bring down the ridership in train to a greater extent than in case of two-wheeler. That's what this means. And this also explains to an extent why the continuous increase in petrol or diesel prices has not brought down two-wheeler or car shares in any of the metro cities, to say in India at least. So you cannot clearly expect two-wheeler car shares or any other personal vehicle shares to drop down drastically just because fuel prices are increasing. Because people are not as sensitive to increase in fuel prices, because fuel prices is the one which basically contributes to your travel cost in two-wheeler and car. Or they don't really affect as much as a 1 rupee or 50 paise increase in bus fare or train fare. People are more sensitive to it. Okay. Similarly, I have coefficients for auto, shared, and company bus costs, and there are many other factors which comes into play. So I'll kind of close this session with the last slide. Okay, you can have some sense of what I'm trying to say here. The auto meter, this is the typical picture in Chennai. It costs 38.2. So I traveled 2.2 kilometers. So as per the meter fare, it is 38.2. But if you see the money I'm giving, 50 plus 20 plus 10, it is 80 rupees. That means for 40 rupees, approximately 40 rupees, I'm paying the double. This is a regular situation in, unlike in case of Bombay or Bangalore. In Chennai, people don't follow regulated tariff in auto rickshaws. They charge the double. That means this is a penalty for the uncertain return ride. They may not get a return ride, and because of that, they charge the double. So I have used my model to just predict what would be the increase if the auto drivers are forced to conform to tariff. So the base shares that you are seeing is nothing but the current shares. And P is equal to 20% means I am forcing the 20% of the auto drivers to comply. 60%, 100%. If I implement 100% conformity to regulated tariff, then I can see an increase of auto shares from 2.2 to slowly 3.2, 6.6, 13%. And what is interesting is, if you see how the two-wheeler or the car shares are correspondingly changing, which is what some of the things that we are interested in. The 41.9 becomes 37.2. So there is considerable decrease in two-wheeler and car shares, which can contribute to other sustainable modes. So you can use simple discrete choice models to understand behavior. My references are the self-instructing course in motor modeling by Professor Koppelman and Butt, and the modeling transport textbook by Arthur. And I once again thank the audience as well as the organizers to give me an opportunity to present on this topic. Any questions are welcome.
So first of all, I thank Mr. Parthan for his nice presentation. So this is a new experience for mainly our students. Generally, transport planning are not much taught in even UG or PG level, because people are mainly concentrated with respect to highway technology. That is mainly payment materials, payment designs, all those things. But it was a very nice talk. He has explained various theoretical aspects and also some practical aspects of that. So let me ask some few questions which has been given by audience.
Yes,
The first question is, you have mentioned regarding aggregate and disaggregate behavior. Now, once you go for a decision, we will go with respect to aggregate behavior. So what will be the use of the disaggregate behavior?
Yeah, this is a very relevant question, and it's already in practice also. Now, by aggregate is not in first place a behavior. So only disaggregate, only when you talk about disaggregate, you can use the word behavior. Now, what do I mean by aggregate? Aggregate is suppose aggregate is the total number of people traveling by bus from this zone to this zone. So we only know the number. Total number of people traveling by two-wheeler from zone I to zone J. This is aggregate number. Okay, now if we only know these numbers from our survey, but the information that we are collecting to generate this is anyway discrete. By household interview survey, when we are collecting data, we are already collecting individual information. So these disaggregate means individual level or household level choices are only translating as the traffic that you see on the road. So if you use this models to study disaggregate individual behavior, you can naturally aggregate it to the zonal level, which we are otherwise doing. But you cannot come back from aggregate to disaggregate. To put it simply, the thing that I just now showed as disaggregate behavior, we can, it is useful in predicting the aggregate numbers. It will again culminate in your aggregate understanding and numbers. But from aggregate, you cannot come back and analyze disaggregate. From aggregate models, you cannot see anything in disaggregate. So that's one advantage. And another thing is, if you want to frame policies, your aggregate models are not useful in framing policies as much as your disaggregate models are. And
Okay, thank you, sir. Now, next question I'll take. You have mentioned different factors of alternatives. So, in that, whether can we include trip purpose and environmental factors? If it is so, how will we include that in the model?
okay, there are two things that you're saying: trip purpose and environmental factors.
Yes.
Now, environmental factors we can. Trip purpose, I will not say we cannot. We can model it, but it is always better to study whichever dimension you are studying purpose-wise, because in most of these models we assume the coefficients or sensitivities to be uniform or homogeneous across decision makers. That means one beta that we are estimating, we are assuming that beta applies for all the people in the population. Of course, you can allow for certain heterogeneity there, but then it is actually unrealistic to expect the betas for a work trip and the beta for a recreational trip to be same. So even modeling wise or even logically, I would not suggest clubbing these two data, both work trip as well as recreational trip, and clubbing them and studying their choice, because these two are totally different choice constraints. In fact, the set of alternatives that is available in a recreational activity or other, say, social activity or temple visit itself is different from a work scenario. So you would better like to have separate models itself for them. It's not applicable, advisable to club trip purposes. So trip purpose, I would advise separate models. Environmental factors, yes, you can. Yes, you can include, just like how we include any other attributes in the model.
Okay, thank you. Next question is, what about this aggregate and disaggregate behavior of logistic vehicle, that is trucks, all those things? Whether can you show some trucks behavior? Generally, we used to study with respect to two-wheeler, car, bus, like that. What about those trucks?
Sir, sorry, I didn't get your question.
Sir, the question is, generally we study the behavior of public transportations.
You're talking passenger traffic versus freight traffic, is it?
Yes, exactly.
Okay. A very good question, actually. To be very precise, we should, if we actually want to estimate the urban travel demand, along with this, we should be studying freight traffic. But you cannot do household interviews. All this is based on data collection done from household interviews. So we need to similarly conduct surveys to predict and study freight behavior. Okay, now this is done. For example, people are studying freight behavior. Recently, one of IIT Madras itself, one person did his PhD on this. He studied urban freight. If I'm not wrong, his name is Surendra Reddy. So they did surveys, and similar surveys they conducted, because both freight as well as passenger traffic contribute to traffic that is on road that you're seeing. So yes, you are right, but the survey that you need to adopt, or the sampling mechanism that you have to come up with, is a little bit complicated. It's passenger traffic, because people travel from home to work, to shop, and come back to home. So there you have a routine, but you cannot say the same thing about freight traffic. Okay, so you will have to do some kind of a very in-depth survey on freight also, which is done. So in case of Chennai, they did with respect to Coimbatore market, they try to track individual vehicles and find out from where all they are traveling, take a sample, and then study behavior. They have done that. But again, we are still in very, of course, in outside many places they have done but I cannot directly adopt that or bring that and directly implement it in India. India, the kind of behavior that you're seeing is different. Yes, you are right. In case of hotels, in case of markets, many places, many other modes like LCV trucks, tempo truck, all this comes into play. Yes, we have to study. So without all of that, our travel demand is still underestimated.
Now, one more last question I'll take. The question is, what should be the sample size for these types of studies?
Okay. You can, of course, there are statistical formulas available to calculate sample size. But there is no one answer for that. It depends upon the city. It depends upon the trip purpose you're studying. It depends upon the number of modes available in the city. More the modes, more the variety of people that you have in the city, more will be the sample size that you will require to represent them, to make your sample representative of the population. If you have very few modes, we will have to only collect very few samples. So sample size depends heavily on the number of alternatives. It also depends on, to a great extent, the profile, the economic profile of that particular city, the kind of variety that you see in the city. So for a city like Bangalore, I would not, of course, this number, what I'm going to say is also not one standard number, because I don't say one given number. Better is I should say that it heavily depends upon the number of alternatives available, the variety in the behavior with respect to mode choice. Again, sample size is not same for route choice versus mode choice versus destination choice. It varies. So whatever you study, that choice of dimension, according to that, you will have to collect that sample.
So,
Anything more than 1,000 would be good, I would say. But 1,000 representative of this population. You should make sure that that sample is representative of the population.
so thank you, sir. On behalf of our department, I thank you for giving a talk on a planning area. So I once again thank you for giving your time and giving a good presentation on planning. So thank you from our side. Thank you, sir.
Thank you, sir. Thanks for the opportunity.
Thank you. Pramod, sir.